Welcome guys, I'm glad you're here. We're going to do a quick video just to get you started, a little introduction to power and a little quick review on some other stuff. Grab a calculator, pause the video if you have to, grab a calculator and work along with me, okay? First, a quick review. Charge is measured in coulombs. We use the symbol Q for charge. It's either a plus or a minus. That's how charges are. Current is the movement of charge. That's coulombs per second or amps. We use I for the symbol for current. And that is always a positive charge. The direction of positive charges move is the standard current we always talk about. We discussed current that way. Voltage. Voltage is coulombs, is joules per coulomb. We also call it volts. That is amount is used as a symbol when we're calculating as V, and the amount is a work per charge. So this is all a review. If it's not in your notes, definitely pause and write anything down. Resistance. We use ohms to measure as a unit to measure, and it's use the symbol omega for ohms. R is the symbol we use in the equations when we calculate ohms. Resistance to current. That's what resistance is. It resists current. Now we're going to go ahead and cover Ohm's law briefly. You remember we plotted voltage and current and got a line, and that was equal to the resistance of what we were measuring in the lab. So that's all a review. Current is equal to voltage over resistance because current is always the output. We can vary the voltage, we can vary resistance, but we can't vary the current directly. So that is why current is the output of Ohm's law. And the symbols for, or the units for that would be amps is equal to volts over ohms. Now this is the new material which we did briefly discuss, that power is equal to current times voltage. The power is symbols. Again, we use P for power, we use I for current, and we use V for voltage. So the units we'd be measuring in would be watts is equal to amps times volts. Let's do a quick review on electrical power like we use in our home. So the total energy depends on the total power times the time that we use it in our home. And we've always used kilowatt hours because there's too many joules to calculate. So we use kilowatt hours for that. That's 1 kilowatt hour is equal to 1,000 watts of power used for 1 hour of time. So let's do a quick review question. I'm sure you remember that we did several of these back when we were covering power. So the electrical energy is equal to power times time. We discussed that. And we have a power of a certain air conditioner. And we have about a 1,200 watt air conditioner would be like a large window unit, okay, for a home. And so if you don't know what a window unit is, it's the kind you actually hang in a window of a room. So it's not on the house itself, it's actually just for one room air conditioner. And you ran it for 10 hours straight. You would just do energy equals power times time. So that's 1,200 watts times 10 hours. So you get 12,000 watt hours, which would give you 12 kilowatt hours, right? 1, 2, 3, move the decimal point, and you get 12 kilowatt hours. So say you were getting charged 14 cents per kilowatt hour. What would that cost you to run a window unit for 10 hours straight? It would only be $1.68. So that's pretty impressive, actually, if you could get, I think our power's running right around that cost, even if it was up to 18 cents. You can see that it's still very, very reasonable. But the amount that an air conditioner draws, the actual amount of watts it draws, is not always based on the rating of the air conditioner. So an air conditioner might be rated at one thing, but when you actually use it, depending on the moisture in the air and the temperature of the outside that it's doing the exchange with, you can really vary the amount of watts that's used. So just keep that in mind. You can't do a direct calculation of how much it's going to cost you to run an air conditioner because there are some other conditions that really do play a big part in how many watts is being used on your air conditioner. Okay, so let's do a quick Ohm's law equation. If you have an alarm clock that draws 0.5 amps of current when connected to a 120 volt circuit, calculate its resistance. So we can rearrange this equation to solve for what we want. We want resistance, right? So if we take I equals V over R and we multiply both sides by R, we get R times I equals V. And then if we divide both sides by the current I, we get R equals V over I. So we can use that equation based on our algebra work here. So the resistance is equal to 120 volts divided by 0.5 amps. So the resistance is equal to 240 ohms. So that's a really simple equation, really quick little problem. Hopefully you had your calculator and you had it done way before me. So you have another one here. We're going to solve for something different, right? But okay, so we have a 12 volt car battery pushes charge through the headlight circuit resistance of 10 ohms. So that means you are just checking on how much current is going to pass through your headlights in your car. How much current will pass through? Let's use the real base equation that we have here, right? We're solving for current. Ohm's law is already solving for current, so that's a win. 12 volts divided by 10 ohms. We get 1.2 amps. So that's awesome. Quick little problem. And now, as you work on your worksheet, you might be building these problems toward a power answer, right? So you might be using one of these equations then to say how much power is used or something like that later, right? So just keep that in mind that you might have a two-step problem as you're working on your worksheet. We're going to go ahead and work one more of these with the diagram, okay? So power is equal to current times voltage. So again, we're looking for watts is equal to amps times volts, and it's giving us the power here, right? So we don't need to use Ohm's law on this one because it's giving us the power usage. So we're just using the power law and we're rearranging it. So current is equal to the power divided by the voltage. That's 24 watts divided by 6 volts, and we get 4 amps. Now, if we wanted to, we could go ahead and solve for this resistor, right? Because now we have 6 volts, we have 4 amps, now we have Ohm's law we could use to solve for the resistor in this circuit. So this is the kind of problems you'll be doing. I'm going to go ahead and say I'm glad you're here. I hope it was a nice short introduction to power and a quick review of some other stuff. This is just some Ohm's law practice you're going to get with the next worksheet you're going to be doing based on the stuff we did. If you have any questions, there's a lot of other resources online as well. Everything should be in your notes. We're always available by email. Reach out to us if you're really struggling with something, but I think you'll all actually be able to go through these problems quite rapidly. Okay, thanks.